Hey, welcome to Coffee Compiler Club. Here today to talk about compilers and language runtimes and type systems and anything and everything to do with, making computer languages go. I have no set agenda, and today I'm a little more scatterbrained than usual. Um, and everybody's recorded. We show up on YouTube in an hour or two. That's the end of the initial spiel. Um, I'll do a 10-second simple update. Last weekend I got simple uh, to read files from disk based on a name. So the simple sys.io.print that I was trying to make do, I want a one-line program that's valid syntax, not a special syntax. It's a valid syntax in the language, so you could just do a hello world in one line. Um, so sys comes up as a variable name. It's not in scope because it's the first text on the line. So he does a default lookup for sys specifically in a system library, which he just looks for from based on the command line, just like he had said dash class path on a Java command line. He finds a sys.o as an L file, opens it up, discovers it's got all the symbols he wants. He sucks in the entire IR because it's actually not that big because the standard library is pretty small right now. And then he links against it, and then I don't have the standard library set up correctly, so he doesn't get any further than that. And then he says, "Oh, I can't find IO now," and that's because I didn't set up how sys.io was technically done. There's a thing here. Where is the God? There's like a random decision that's not very deep that I kind of ignored. And then it's time to get serious about it now. So the sys dot simple file here is I don't know how you get a file header going. And Matt's trying to tell me I can't say deprecate, I can't say half of the fancy. I cannot never spell necessary. Um, so this has got somewhere buried inside of it. It's got a struct IO. Let's just see. And this struct IO is inside of a class sys because that's the file for struct sys. I don't know if it's class yet. And then this has a print, var print equals some function. Okay, so in the namespace universe, I end up with IO is actually being sys.io as a nested namespace. It's not a subclass. It's just a nested namespace. It's like a Java interclass. It's a nested namespace. When I emit the code out to the ELF file, in my head, I'm thinking there is a sys class object or struct object, a singleton golden sys object. It has a field IO, which has itself the singleton golden IO instance. And so when the user writes as the next thing here, the user's, one liner program is sys.io dot print hello world.
Did you share your screen? Is that important?
Should have shared my screen a long time ago. Thank you very much. I'm just doing Google Docs, but I didn't tell anybody that, so everyone's staring blankly here. Yeah, this. So there is this file here. This is the standard lib file. And I compile that separately as I'm compiling standard lib. And he has some stuff in it. One of them is a struct IO. He has some other things in it, but struct IO is in there. And an IO has itself got a print function inside of it. And so, I want to say sys.io to print. And when the user writes sys, I do a lookup for sys in the current namespace, don't find it. I do a lookup in the global namespace as made possible by the command line that said, go find the rest of the program, another module somewhere else. He finds the sys compiled module. He opens that up, semantically saying, okay, everything inside of here is inside the class or the struct sys. And he loads that ELF file in and gets that IR out. And then this syntax is supposed to say, go find a field in the sys thing, which better be a struct. So here's the struct. It's the whole file is the struct. Within the struct, there is a variable called IO that will itself be another struct. So I didn't write and it's assumed, but you could say I have this. Here is another way that syntax could have been done. I have an IO field. It's a struct that contains a nested thing, and then I am on off to the next layer of things. In fact, I could argue that syntax is the right syntax. Anyhow, I did have it set up right, so my sys.io stopped at the lookup of IO in the sys object, which didn't find an IO field. And now, having said that, I could go to this as the standard way of simple writing a new struct. That is to say, you have only anonymous structs, and you put them in a variable if you want to give a name to them. Or else you have to have a different syntax where struct has a name on it, but then I'll make it a global, that same name will be a field in the containing class object. It's sort of a minor nit on how you do the language design. And I like always having everything anonymous so that you only have this one place where names show up. They show up when you declare a variable. And otherwise, they're always anonymous. No one else has to deal with having named anything. It's just when you declare a variable.
You can exploit that further, I think. The var and the val should signify.
Oh, I probably should have said val. I could even require it to be a val.
You can exploit that further. If you mean a val, that would be a data
Yeah.
type, a case class for in Scala or something like that. All of the fields are immutable. You can exploit that
Yeah, this
further
should
if you want.
be immutable. So if I have an object, so it's a long-standing goal is to say if I have an object which has immutable constants, like val print is immutable for being a val, and the function's a constant because it's a constant, because functions are always a constant, then I'll move them up into a class object somewhere, and not every instance will pay the price.
Mm.
So, so here, if I were to make an IO instance, it would have no fields in it. It would have be size zero. Maybe some metadata, but otherwise size zero. And then the print field, because it's the same for everybody, is stored in the class structure for IO. And then you look up for the IO for the print field in an IO object would fail in the no fields in the IO instance, and then go to the IO class and discover print. And so you basically make a static call to the print object. That's what I was doing with AA, and I probably could get away with it here and make life more consistent. That's what that goal here is. Make life more consistent. Okay, why is sorry, somebody's badonking me. Okay, fine. The last 10 o'clock meeting is setting me up with badonks that I'm going to ignore for till coffee clubs are done. Yeah, so that's where I'm at. I'm actually loading the IR. This, when I compile this guy, he makes a standard elf. It has executable code in it. You can link it with a normal linker and call io.print if you have the right name with a standard linker from C code. It's all good. Or you could load it into the compilation of the Hello World program, who promptly sucks in the IR and wants to actually optimize through the IR. So I don't know if you call it link time optimizations or whatever, but he would have the full IR present and available, and I could just call the native binary I already have, or I could link against the IR and optimize and produce new code for the inline whatever things.
And you wired it up to standard in and standard out so you can read and print?
Yeah, it was standard in and standard out wired up a long time ago. So print itself, yeah, is wired up. So the IO struct has other things not mentioned here, which has FFI calls for read and write, which takes uh, file descriptors, Linux file descriptors. And so print, uses the file descriptor for standard out and calls the write call and turns the string into an array of bytes and then calls write. And that works. So I actually can, this program will run if I fix the naming that I've done with IO here. And I've had it running in the past. So I know I got the IO wired up. I mean, that part's there. So this is hopefully this weekend's project to sort that little bit out and then standard lib will let me at least do hello world using standard lib as a standard lib. It's been a month, but I got busy. I've gotten very productive at hashgraph, and I'm now moving my 2x speed up into the standard PR and all the official tests. It's got to have some more testing done. People are all nervous, but they're going to get it. They're like piling in on, hey, this might work. So I think in a month or less it'll be in production, and I'll be on to the next thing. It's all good.
Nervousness is a good survival instinct.
I'm sorry, say what?
Nervousness is a good survival instinct when you're changing the engine on your plane in flight.
Uh-huh. Yeah, I know I'm not running that business. I'm no qualms with what they're doing about how they manage the rollover. They routinely roll over. They have to. You're in a competition with every other Bitcoiny thing on the planet. So everyone's feature fighting, and some of their features are like stability and governance with what do we call them? Governance that's suitable for government work. So they're
So that's definitely
definitely,
what C++ and Java have taught me, is that stability is the first feature.
yeah. C++, huh?
If you keep breaking people's code, they'll.
Oh, if you change the language to break their code, yes. Yeah, Hashgraph's a different stability problem. The running engine that's doing transactions on real money, like an exchange, like New York Stock Exchange, it's not the volume, but but people don't like it when you accidentally burp and lose their $1 million. So that's stability. Language stability is actually, yes, is there. Right now, I get to hack simple to my heart's content because I'm the only user. Were I to not be the only user, we'd have another conversation going on. Uh-huh. Anyhow, yeah, some progress, and getting excited with progress.
And you're still managing to do simple without any kind of import statement. It's entirely based on the structure of the file system.
Yeah, yeah.
I,
Let's see.
I
There's
also
Like
a
when you say
sim
sys.io, that literally means look in the sys folder in the IO folder, in the IO.
Basically, it's not the requirements are a little looser than that. So there's a command line. It has to start with Java. It has to have your simple or simple jar. Let's just do a simple jar here. So that's your normal start. Now that you're running simple, what else did the arg say? Well, one of them is the simple class path. Oh, and then somebody's doing a chat thing, and I've got my chat window closed. And let me open chat window and make sure I figure out what I'm doing here. And Ryan has something to say too. Just give me a minute, Ryan.
And the
But yes,
simple class is like the bash path. It's I will look at these exact folders in this exact order.
yeah, yeah. So
Because I
build
think it's important for
obj,
order to be meaningful there. Otherwise,
right?
life gets complicated.
Blah blah blah. So something like this. So dash CP for class path, and then you could have multiples. I don't care. And then the file here, right? So in that CP twiddle build obj, he will look for a sys.o. So when I compile here up at the sys file contents, the directory structure here is build slash ob slash, there's a sys.o. You're allowed now to have a sys slash, and then within sys slash, you might have an io dot simple, or i.o.o, sorry, and that could have itself an io slash dot 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 whatever. Um, you can put file extra structs in the file system in a nested directory of this naming convention, or you can leave them inside of here. So this, if this is the file for sys, then I don't need the io.o because this will produce a single elf file for sys. In that sys io file will be the sys struct, the IR for that, the compilation of the IO struct, the print function will all show up in here. Right. So this is as described above, this has the symbol sys, the symbol sys.io, the symbol sys.io.print, code for all, data for all. And it's a classic ELF file. It'll just splat all that stuff into memory and then, find the main and go. If you compile against hello world has your main, but he'll pick up everything from the sys.o file and splat it into memory and link against it with standard ELFy things. Under this configuration, if instead, when I compiled sys, I put the IO pieces in a adjacent file in the same layout as this, so it'd have to be a sys.simple and a sys/io.simple, then he would include IO as inside, as a nested namespace inside of the sys. So you can have it either way. You can either put it in the file if it's small, and you can put it in its own file if it's big, as long as you preserve the directory structure.
Does this mean I have to go through a compile step first?
Um,
Because I noticed you're looking at
somebody,
IOs. I didn't hear a step in there that was like, and I noticed that there was a .simple file that was a more recent timestamp than the .o file, so I'm going to rebuild it.
I don't have that in place. It is my intent to do that. I'm expecting the standard lib to show up without any source code, and therefore you won't ever trigger the go compile the standard lib again. But if you have a directory structure of a large project, you can edit a bunch of files, and you go say, go build and run this one file, and the one file depends on another file. I should, in theory, do the timestamp check and then compile the other file as well, recursively until everyone's brought up to date, which is basically what Java-C does.
Yeah, but I think
So
there's a
you
lot
get
of value in making that make step go away, where you're just like,
yeah,
I point this at a directory, and it's a little bit slower to do loads because it's checking timestamps every time you load a new object you haven't loaded before. But
it checks, would have to only check two files instead of one. You're loading a .o. Well, you check
right, you have to check the timestamp on both the .o and the .simple.
Yeah, but that should be pretty quick.
And if the .simple is newer, then compile.
Yeah, but checking timestamps should be quick. Like once the inode's been loaded into the OS's cache for the file, the timestamps they're microseconds to go get. Now, microseconds on a million
I usually
file
think of those
project
as a disk seek, or I suppose now I should think of them as a flash read. But
yeah, it's a flash read. I'm thinking okay here. Now, having you said that, there is one that says I want to have some control over when builds happen for whatever reasons. I have reasons. Then there's a version of that that says skip the time check on the incoming source, and therefore I will link against whatever your current, perhaps outdate .os are. And I'm okay with that too. I want to control my build process mindset piece, which I'm okay with. So if I have a default, you compile, you do the time check and compile as needed, and you can turn it off if you want. I think that'll be the obvious way to go.
Yeah, but I would definitely lean toward those checks are on by default and off only when you ask.
And off when you ask, yeah. And
because again, you want the default path to be simple because this is a teaching tool.
Yes.
The number of times I, as a TA, have had someone come in and be like, "This is my code," and I save it and I run it and I change it and I save it and I run it and nothing's happening. And it's like, did you build? No, that's why you're not changing behavior.
Yeah, because there's an in-between step that produces a file that has state. The state wasn't getting updated, so you didn't see it, and you didn't understand. You have to build that state model in your head of there's a source file, there's an object file, there's an execution.
And that's why IDEs with a run button are great.
Yes. Well, you have to teach students somehow because all kinds of systems on the planet don't work always that way. You have to understand what they're doing. I get why you have to teach it. That's kind of my simple update. I'm going to fix the layout I did wrong here. I'm not sure which way it'll get fixed. This is basically working, except I don't do the extra time step and nested compile. That's not happening. But I can get to a time step check and blow up at you. That was my other option, was to say, this is out of date with that. Either don't tell me where your sources are, or compile your sources first, your inputs first, and then compile this guy.
I'm curious what made you lean toward having a build directory versus just dropping the .o files next to the .symbol files in the source directory tree,
You
whatever
could
that shape
you could
is.
there are two different thoughts in my head running around here. One is you could totally have the builds file directory be your current directory tree, just and it will drop right next to you. Um, and then in large projects, it's convenient to, from my head, it's convenient to have a separate build directory for all kinds of crappy things that show up that aren't related to whatever you're doing. And a make clean is a remove the build
Is
directory.
simply deleting one directory.
Yeah, and it's all like it's done.
Well,
So I've
also,
definitely seen Python drop its little PYC files, and it usually drops them next to wherever the source file is.
Right. Right. You get these turds in your directory that, they're up to date and they're nice to know that you can tell, to verify, blah, 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 timing this and that, whatever. That stuff's usually pretty reliable.
if you
But
have
yeah, maybe it is a nicer semantic to just have all build artifacts being built.
Well, also if you have more than one architecture, like systems languages usually do, you can reuse. You can say, okay, this source directory is this network mount that I'm accessing from my Mac, my Windows, and my Linux PC, and then the build directory is somewhere else. Whereas if the build directory is like tied to the repo, now all of a sudden, you build it on Mac, and now you're on Linux, you can't run it anymore because it overrode all the build files.
So naming conventions for the targets, like I make a .o, but is it a .o for your current machine or are you cross-compiling for some other machine?
Yeah, so you want to have separate build directories because then you can mount your source files as a network share, right? And then you
Yeah.
can like edit it on Mac, and then you can go to your Windows PC, and you don't have to like do a git push and git pull. Like it's already
That's a
there
good
because
one.
it's a network share.
Yeah, it's a
And
network share.
then your build directory doesn't have to be a network share. You can just have your build directory be local, and then you
Right.
update one computer, you compile it, and then you update it on another computer, you compile it.
Yeah. I mean, that's morally having a differently named build directory for the different targets you're running from.
Right,
Result,
that's
in
what I
your case,
mean.
you spread your targets out across different physical platforms with different chips. So they have a
But
root name that's different based
you
on the
you,
amount.
you need different build directories to do that, though.
Yeah, and you need
Like if
different build
you're
directories for that, and which you've done by mounting them on different file systems. So the Windows one and the Mac one and the Linux one all have different file systems that they're mounted on. And that changed the build directory name effectively, which is
right,
perfect,
but
which is what you want.
if you put your O files in the source folder, then that doesn't work.
It's
So I'm just saying
so
there's things that having it separate enables.
it makes it more convenient. I could rename the files in the source directory as well to have the chip and architecture on them. So they could be, sys.o would be Win64 under x86 v2.o or some stupid thing. And that's ugly in my head. And a build that says build slash Win64, blah, 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 slash, and then the files as a tree with just sys.o looks better. And right next to that build will be another build as a build, the same build, but then slash and Mac OS, underbar, ARM, whatever, slash, blah, blah, blah. And then, so you could do it on the same file system with renaming under the build, but you have to have some renaming somewhere. And I'm with you that the build name is the place to do that renaming, which immediately means you want to build target place. But you could say the build is, I could even give it to you by default. Your build target is your current directory, and then it lands right next to your source code. And for a tutorial, that's probably what you want.
Yeah, the other just make life easy for tutorials is to say if there's no class path passed in,
Yeah.
to have a reasonable default there so you don't
Yeah.
have to teach a class path on day one.
Right. So I'm throwing down class paths here to tell you guys, but my head is upon installation time, you grab the simple jar. Well, the class path to the .o files for the pre-compiled system library went in at the same time, and you'll just find it that way. So yes, the easy launch line here would be some simple executable. I've done java-jar, blah, 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 but some simple executable, and then just hello.simple, and he picks up class path. Yes, default class
Yeah.
path.
And my personal recommendation there that I would default to is the highest priority is the directory where you found the file that you're
Simple
trying to
jar.
run.
directory
And then the
found simple.
second place to look is wherever simple.jar was.
Oh, first place is to look in the directory where
I
hello
would look in
is.
the directory where home.simple is,
Oh, okay.
and then in the directory where simple.jar
But
is.
what is home.simple?
I'm sorry, hello.simple.
Oh, hello. Yes. Okay. Oh, in the current directory.
You're
Yeah.
saying go execute this file.
Yeah. Then you go
So
override.
the first place I should look for stuff to execute is, well, what is the directory that had the file in that you told me to execute?
Yeah. Okay.
Is the file that you're calling next to it?
Right.
Is the file that you're calling in a folder that's in that directory and then going down?
That
And
makes
if
sense.
you don't find it there, then it's probably the system libraries, which can easily live next to wherever simple.jar is.
Right. Yeah. Oh, we have Mark is trying to come in here and more people showing up.
That way, all the stuff that ships with simple, you can just put in one directory. The installation of simple can now be unzip this file.
Yeah, I absolutely want the installation to be unzip. Yes. Right.
And now
Yeah.
all the standard library stuff is just in the same folder with simple.jar.
Yes.
And all of your code is in the same folder as main.simple.
Yeah. Yeah.
I think
that's
that would
what.
eliminate most people's need to have a class path most of the time.
Yes. Okay. I'm done with my simple update.
Okay. I can give a quick update on mine. I've been working on the graph debugger. I have a working like user interface, and I've been trying to optimize it a little bit. So a lot of it was AI code, and it wasn't too good. I think I've mostly got it in a good state, but it still needs a little bit of work.
I've
Did I
been
show?
been
Did I
been
show the
working with
UI?
AI code this last 2 weeks, a little more often, and I'm enjoying. It's interestingly good and interestingly bad.
Did I show the
I
graph
like
debugger last week?
it's like a very good intern that's eager to please
Oh,
and
so
does
eager to
really good
please.
work until it completely doesn't do really
Just
good
just
work.
just borks the yeah, just borks it up. Yep.
Did I
I
demo
Sorry.
very much
the?
had the I'll fix this by deleting it experience recently.
Uh-huh. Okay. No, I'm not there yet, but I've had
Bugs are gone.
some real winners. Sorry, Ryan, go ahead.
Did I show the UI last time? I don't remember.
You were trying to, and you said you've got some improvements made. In theory, I've unstuck sharing, so you should be able to share.
Okay. Okay. I think maybe if I already shared it, but it's basically the same now. So I've just been like basically adding some performance, and then I've got uh a thing where I can now like serialize the data and then load it from serialize. So I'm about to add files, so I can actually like instead of just having this compiler have a hard-coded function where I'm like, okay, I'm just gonna launch the graph and then haven't edited my code. I'm just gonna make it like spit out the graph dump as a file, and then now you could just load it with the open file button. So that's my next step. I got the serialization working, but the it's still a little bit yeah. I don't remember how much I showed. I'll share my screen.
All right, Matt, I just finally read your comment. That's hysterical. Oh my God.
I'm not sure how this is gonna work if I share CLAN. Like press run. Okay. So it'll do this, and then it creates the
Oh, this is your execution as a graph,
yeah.
and
So
you have
it
some
now it
debugging
has
things.
a UI window. Let me close this one, and then it'll open the second one, and then I'm gonna stop sharing and reshare the UI. I don't remember how much I shared last time, so probably this is pretty similar. But yeah, so you could just be like, okay, here's the node. It's got an input and it's got an output and it's got a type and then the summary. So this node is Fibonacci of 30 and it has dependencies. So you can look at the input and the output and then any messages that get displayed. There are no messages on these, but like you can scroll through here if you have like a debug message. So
And
I could
the dependencies are things that are memoized.
yeah, essentially they're memoized.
Okay.
So you can have like It's more than just memorization because it's like they're coroutines, but yeah. So
Okay.
yeah, that's that. And then as soon as I'm done with that, I'm going to integrate that into the compiler. So I'll have my debugger and I'll finally be able, because like finding bugs in the graph structure of the compiler has proven to be very tedious. So that's why I'm building this like GUI and all this stuff to like go and find stuff. And then I'm going to add a storage type. So I've been kind of thinking about how to implement the storage in the interpreter. So I don't have a good answer. I don't know if anyone has any other topics, but like discussion about how to implement interpreters of storage types could be another topic, maybe.
I was going to go a different route, and that is every time I've ever worked on any compiler-based, execution-based system, I always end up with some sort of custom debugging help. And I turned my PR hashgraph from draft to real, and then people popped up and said, "This thing's full of like these debugging things," and I'm like, "Yep." And is it going to stick around? And I'm like, "Yep." Custom
Yeah,
debugging is a de-rigger thing for language development in my head. I mean, just what I've seen. Everyone ends up doing it. And another piece of that is everyone has the ones they love, and no one else likes yours, and you don't like anyone else's. They're all very personalized. It's not entirely true, but quite generally, all the debugging add-ons that I've ever seen used and had other people use mine. You like your own, you don't like anyone else's. Uh,
yeah,
what to do about that in a large-scale production development system? If several people need to work on the same compiler, then there has to be some agreement on what the debugging tools look like, when they're used, how they're used. I guess
yep.
C2 got there.
I'm hopeful that this is going to make things a lot easier.
Yeah, yeah, yeah.
Because
You got to have something.
I've been like running the like print statements, and then it's just like because there's so many nodes in a compilation
Yeah,
now, it's just like Control
right.
F, and then I'm searching through like
You drowning in those. Yeah. The
yeah.
C2 simple both have that. Simple's not so bad yet, but C2 I would get tens of thousands, occasional 100,000 nodes. And a lot of effort went into printing them nicely and laying them out and making them organized so you can quickly scan. And then have a button somewhere, which usually Control C, Control V, would just copy it from the output dump into Emacs. Now, if I'm debugging in Emacs, it's already done. But you get that dump in Emacs, and now you can, fold, stable, mutilate, search, edit, replace, find what you're looking for. So I say Emacs, but you just pull it to an editor buffer and use your normal editor tools to like work your way through the pile of nodes. And then I add comments and I break out important pieces and mess around for a while. And then suddenly I like have an inspiration by staring at things I've sorted out. Oh, this thing's missing the blah, blah, blah. Well, where did that get broken from? And then I have some bug to go chase down. But yeah, debug prints, however it's done. The graphical one, I'm curious to see how well it goes. Bunch of people tried graphical prints for C2 back in the day. There are better tools for that now. I know you guys somebody was online here when I did a tool. I still have that tool running inside of Simple that produces a graph layout. And then as you single step the graph updates, he modifies the graph in place visually. The layout tool, I think it's D3. Anyhow, it doesn't have any clue how to deal with, it's dot. Doesn't have any clue how to deal with the control flow graph per se. So he does a terrible layout job. And so it wasn't super productive. As soon as you're past trivial for a tutorial, it's okay. Past tutorial stage, way too bad a graph layout to help with debugging.
Mhm.
I've seen better debugging, better graph layout tools, no time to go add them in, but that's a definitely a thing I want to play with sometime. You know what? This is a job for the AI. Go ahead, Mr. AI, see this tool using dot. Okay, make something better using this other tool and integrate it and bring it in. Set it up in the build, set it up in the linkage I have going here. Let's see if we can't get a better visualization tool. Fine.
Okay. Yeah. The if no one else has anything, the other topic I had was like storage types. So like part of my language is that there is like a constexpr interpreter. So like it's a compiled language, but there is like a comp time or constexpr interpreter that like executes.
Right.
And so one of the types in my language is like a storage type, which is like kind of like a union potentially, or like something. It's like uninitialized storage that can hold an object of potentially one of several types.
Okay.
And so my thought is like
every interpreter on the planet has a boxed value to hold something that's one of 17 different flavors. Yeah.
Right. So my thought was like, what's the best way to implement this? Because like constructors, like, so like
is box different than tagged union?
It depends where the tag goes, but not really. Like the hotspot interpreter.
Tagged union is one possible implementation of boxed.
Uh-huh.
Got it.
The hotspot interpreter, every stack slot is effectively a box with no tag, and the tagging's done when you first run the verifier over the bytecodes. They are strongly typed, and you can tell what's in the box based on what the bytecode does.
Yeah. So the storage type is essentially an untagged union. Like it represents the like storage, that space you could store an object in. And so most of my like instructions that I have implemented in the VM for constexpr don't like do any kind of type checking. They just kind of assume that the bytes are of whatever type of object you're accessing.
Yep.
And so this like for constructors, I've realized that in order to actually do this, I need to be able to, instead of like taking a reference to a slot, I need to be able to like take a pointer to something and then pass that to the constructor as this argument. Like that's how I was thinking of implementing it, where it's like it like nominally it takes a reference, but like if you pass a pointer instead, we'll just call it like placement construct or whatever. And that could go to like an arbitrary memory object and not necessarily like a local that is like of that type.
Do you need these things to live in a uniform address space like an array?
So the interpreter uses like a logical memory model, not like a it doesn't use like a realistic machine memory model. So there's no contiguous address space. It's like, okay, this is like an array. It contains like sub objects essentially. And so
I would tag your unions for safety's sake, and you'll probably find some bugs early on. And then you'll forget that you had the tags because all the bugs will be cleaned out so fast because the tags catch them so quick. And then you'll go a long time with the tags and they're not doing any good. What the hell are these tags for? But you had them to get past the hump of, I had type errors somewhere.
Well, there has to be some kind of tag because like you can access it incorrectly, like in the interpreter. So you could use it one way and then you could do it the other way. And so
the Java interpreter does not need the tags in the object because it has its typing done at a different level. But if you have a sort of a classic interpreter where you don't do that, you don't pre type check the bytecodes, then yeah, you want to tag per.
So I'm thinking like, should I just like tag its current type and then like how? Because I'm imagining that might had like a fair bit of like overhead on doing like load and store operations. Because like if I'm checking the type of the object is what I expect every time, then maybe
this is the tension for every interpreter writer on the planet ever. You go look at Java C pre-jitting and how do we squeeze what kind of bits in and still have tags? So if you have this tag somewhere, squoze a bit, you're a pointer, but the pointers all have the low 2 bits 0 because we all go to a boundary of 8 or something. And if it has this, then it's a float. And if it has that, it's an int, but only int 57. So it's actually the float subset or blah, blah, blah. There's some way you're trying to pack and squeeze ints into 64-bit entities or 32-bit entities or worse. And you had to give up on some bits here to get some bits there. And that was always the tension.
Yeah. So I'm wondering how I would like minimize the performance impact of having these like tags on the like storage objects. So I was thinking like there's a couple different ways, right?
Yeah, well,
Like
wait, back up. So go back to that question. I'm minimizing the performance cost of the things I'm running in my constexpr interpreter. Is that your goal, to minimize the cost of running constexpr? Is that the goal you want?
well, if I can do it without like making a massive impact, yeah, like obviously
If
it's
it was free, you take it, but it costs you engineering time. Where do you want to spend your engineering time?
that's a good
That's what I'm
question.
saying. Think it through. Maybe it's what you want to do, and maybe you'd rather get fast and dirty on the constexpr interpreter, correct? But it can be slow, and move on with other more exciting things. Or not.
Hmm.
Maybe you called it right. Be intentional here. This is a decision to be intentional on.
I guess there is an argument that maybe I should just get it working first and then not worry about the performance right
Be
away and just be
intentional.
like,
Choose. Don't accidentally fall into it.
I'm just wondering because I'm thinking like if I'm doing a load of a type every like load or store operation, that's gonna be like that's gonna like double the execution time.
So the other piece of this, of course, is that it's a lot of fun to optimize this shit. So you have to think on, oh, what I can do this, I can do that. Oh, it's out of this. Okay, fine. So
So
you can drive that cost of the load and store checks really far down. So if you have, for instance, preserved that the low order bit is one if you're an integer and zero if you're a pointer, as just a two-way split because you only got one bit. And then if you have a pointer, the value is correct. You just check the low order bit, branch equal or not, and mask the low bit and equal or not, you got it. Or high bit, and then you do overflow or positive or negative or whatever, and you got it. And then you had to branch, and then on one side you're an int, except that one of the bits is weird, and the other side you don't have the bit, and it's a pointer, but the pointer is cleared if you set the points right. The pointer has the right higher order bit, which is done. And if you put it on the high bit, actually, now that I've said that, then things like adds and subtracts and shit overflow into the high bit, and you just ignore the high bit. So you only have 63-bit math instead of 64-bit integer math, but it's all just do the math, and you had one bit tested. It's a pointer, I'm going to do the pointer thing. Oh, it's an int, I'm going to do the int thing.
okay,
You drive that cost pretty low, I'm saying.
so I kind of thought of two different ways I can structure the storage interpreter, right? Like one is I could have like different variants. I could be like variant type one, variant as type
Right. As
two
as
is
soon
like
as you
fake
as soon as you
structure
have a
members.
bit test for the different variants, you can start to branch out into ever lower frequency things. Oh, every now and then I have to handle 128-bit thing, and so one of my bit patterns is sends me off into the weeds to some slow path that deals with whatever's UUIDs or timer or
Yeah.
something.
So I was thinking like I could have my storage object have like substructure members, and those structures are like the different types of objects that could be put into
You're talking
storage.
about when you write the C version, the C++ code.
Yeah, the constexpr, right? So like at runtime, this is just a chunk of storage, right? It's not like when I'm actually executing this in compiled code, it's this chunk of storage, right? There's no
Yeah.
type checking or anything. But like in the interpreter, I'm thinking, okay, I like construct a skeleton for each type of like do I force you to declare all the different types that can be put into a
This is
storage,
your own
right?
system for what you put in your const experts, right?
Yeah. Yeah, so
Yes.
I could have it like this storage T1, T2, T3, and like you can use one of those types and it has to be one of those, and then I can like pre-fill the object skeleton structure
Yeah.
like by constructing the storage, or I could just say align and size
So
and then
put your comments like that in the docs we can share. Matt's throwing interesting things in the chat, and the chat is like a difficult place to have interesting editing and communication.
okay, let me open
Um,
the doc here.
and he's pointing out all the fun ways that you can do bit stealing. And what we're in the zone of is bit stealing here. And typically you're very tight on the one of bits you want to steal. So you
Oh,
have
your doc link is the wrong one again.
why is docs not shareable? You can't share docs? I shared the docs.
You
That's
you
fine.
sent the link is the 27th of February.
Really?
Yeah,
Oh, no. What?
Where's the link? The link to the doc?
Try the one from the
Throw it
chat.
in the.
I send it in the chat.
Yeah, the one on GitHub is also run for me. It's also the last week, I think.
Yeah,
Boy, you're really hard
the
to
link
understand, Matt. I couldn't hear. Your mic was very echoey.
Okay.
I have to use Google Groups now to send this meeting. I have to edit a prior group.
Oh, I was looking on Discord. That's where I didn't see the new.
And I didn't put the
doc
new
link.
one on Discord. Okay.
Okay.
So
Like,
this should be the new one. Yes.
option
Open.
1.
And this is the doc, and I claim my doc ends in 6GIU, and this is 6GIU. Yes, I sent the correct one. I didn't update Discord. That was the mistake. Okay.
Okay, so the pros here is like no reallocation when changing types. And then option 2, option
So
1.
instead of no reallocation, it's no reallocation, but also you have to change the type tag.
Yeah, so option 2 is like size
Just go allocate.
align. Yeah, so like option 2 is like this, and then so it would just be like current
Almost
type.
surely option 2 will be vastly slower because you're doing an allocation. And then you're fixed on your sizes. Yeah, if I was doing this in Java and you're not, then if I needed to have something at variable sized, I would go ahead and declare that rarely happening and allocate. And then let garbage collection pick up the junk. And if it was going to happen more than rare, I'd be pooling.
Because like a structure is not like the VM doesn't use like a memory layout. Like it like a field is like a sub, like there's a pointer to the field, kind of like it's a map of string to
you're in a compiler.
sub-object.
You're trying to run an interpreter on constexpr in a compiler. I claim don't optimize, make it clear and obvious. And if it ever comes around as a performance problem, then you go deal as optimize it. But you have a low use, small bit in the big picture of compilers. Yeah, the size limit, the issue with the fixed size, what you're not saying here is like option 1 in my head is there's a tag and there's a fixed size to distinguish what the rest of the bits mean.
But also you also get stronger aliasing analysis with this option, right? Like
now the aliasing should be unrelated. You should no one cares. Who cares about alias analysis? That's a performance hack.
Right, I'm saying, but like if I make the language use this option, right? This affects both the VM.
Wait. I have a confusion that I want to sort out. One is I am writing a interpreter for my constexprs, and that will in turn eventually go down to what the rest of the language means or does, how it executes. But the language of the constexprs is defined by whatever my language means when I'm doing code evaluation. And I need an interpreter for it who has to do the semantics of that language. But it's not what I'm in. But you have 2 compilation steps here. You have an execution step for constexprs, and then you have a post-compile execution step where having compiled the program, you run the compiled binary and life goes. So you have 2 execution points. The constexpr 1 is in the middle of your other bigger compiler step. You have a constexpr piece. Is that correct?
Yeah. So there's 2 different, like, you could either execute a constexpr or you could execute natively, but the type would be the same. So like if I go with option 1, that might also affect the compile code.
So the natively was during compile, I didn't run a constexpr, but I generated code that would do an execution. Then at runtime over here, I run that code and it builds up what I know to be a constant, but I didn't want to bother emitting, pre-computing it.
So
like 2 choices that you're making, and it's all fine.
My thought was that if I embed these types as part of the storage type, then I know that like even if this like pointer to the storage gets exported out of the local scope, if a function is called that like mutates objects
So
of
now we
type
have to back up
T4.
again because now what I'm hearing you say is I have this constexpr interpreter, and it would normally in my head, not yours,
Well, this
it would
this is also
normally.
part of like the language itself. It's not just part of the constant. Like it has impacts on both.
That's what I'm trying to come around to. Okay.
Yeah. So like
You're self-reflectively using portions of the language to run const exprs in the language as part of the compile step, but these might also be visible outside of the compile step and show up in the
yeah,
eventual runtime.
yeah. This would be like the actual way. Like I'm thinking, how do I implement storage types in my language? Like as a general
Okay,
point.
that's a
Like
different
so
problem. Like storage types for an interpreter, one plan. You have a different question. What are storage types in general for your language? And that's a whole like what do you want your language to do question.
so another kind of thing is like I have if I have a fixed set of types that could be in a
Yeah,
storage,
yeah,
then I can do alias analysis. I could say, okay, this function only stores to objects of type T4, therefore it can't overwrite something that's stored inside a storage of types T1, T2, T3, even if
yeah.
T4 would fit inside that storage. Whereas if I go with this option, then I don't have that. But this is less flexible. Um,
Well, there, okay. So as soon as what you just said now says, here's my total language design, what I do with memory. And if I look at what happens with Java, I immediately break up the world of memory places, what you're saying is storage, into these alias domains. And I know that no array ever points to a Java object and vice versa. They are just unrelated things. And I know that no field of a particular name overlaps with any other field with a different name. And generally, even same field, same name if they're in different classes. So, cat.name may overlap with dog.name, but cat.name never overlaps with integer.value. And so I get these alias domains based on the naming that the user gave me, the types the user gave me.
yeah. Yeah, I guess that's true. Like I could just say, okay, well, if I'm like, I guess this is like the laundering problem, maybe.
You're
So
bin packing or something weird. I don't know what you're trying to sort for here. Like, why
like if I
why are these
if I
storage things existing other than they're just chunks of memory? What you mean by them is there's chunks of memory, and you're going to have pointers into them. And what are the aliasing rules and the pointers into them?
yeah,
I'm
something like
kind
that.
of sorting out what you're doing here. In a general purpose programming language, I need memory. I grab some memory. What are the rules around the memory chunks I get? In the land of Java, I say new, I get all this memory that's co-adjacent, but each individual slot has aliasing rules based on field names. It's easy. If I go grab an array in Java or C or any language, then I have indexing problems where the aliasing depends on what I can discern about indices. And that's crucial for some domains and kind of don't care for other domains. If you're doing HPC computing, oh, you care a whole lot about how those indices overlap because it tells you how you could keep the semantics the same but reorganize the arrays. And if you're doing non-HPC and you just have an array as a collection of things for a hash table, an array list, whatever, then you don't care a whole lot about how the indices alias to each other. So there's this, what do you intend to do here? And what I'm seeing is I have some amount of storage that's going to be fixed size and have tags to say who's in it and who's not. And that's going to be part of my everyday runtime experience. Then you're headed for like a Python-like experience where you're like interpreting all the time as your normal execution. It's maybe not what you want, not what I'm hearing
Well,
you normally want.
at runtime it would be like you'd be like you might have like I don't know. So you have var s storage, like let's say we do this one T1, T2, T3, and then you'd be like, okay,
So semantics
um,
here, I'm
this
guessing, I don't know. Semantics here are I'm under the hood. I'm going to have a pointer to a wad of memory, which is a tag alias, a tag union.
yeah. So this could be like C get T2. So something like this,
Yes,
where
it's a
it's like
tag union.
it's untagged. So this
You
is
say
like a
untagged, so it would be okay to construct T2 and then c.get T1.
I mean, that would be undefined behavior, but
But
you
but
could
but
write
your
the code.
compiler and your runtime don't stop it.
Yeah, the the runtime wouldn't prevent it from happening.
Okay.
In the native code. In the constexpr it should be caught, but not in the native
Okay, so in the native
execution.
code, it's just like a C tagged union, untagged union, C++ untagged union. If you misuse the bits, you misuse the bits, and bad on you.
Yeah, basically.
Okay.
Or maybe I call this like as, and then
But
you
I
could do
mean,
like,
so far in your current description here, I mean, I go to this in C code, I would just malloc and then cast it to a T2 pointer and use my T2 space or cast it to a T1 after I filled it with T2 bits, and then I call free. So this is, morally equivalent to the C code that says malloc and free and cast after the malloc.
yeah, but you can't do that in constexpr. Like I don't think you can.
Well, what
At
does this have to
least
do with constexpr? Like a constexpr is a thing you're going to do in your compiler to execute constexpr. I know what it is. Okay, here's your
yeah.
runtime thing. Now, why are those two tied together? Well, why are you tying the runtime storage construction with the
Well,
compiler's
because
implementation?
because I want to be able to like execute things in constexpr, and like I can't think of a good algorithm for like do it like malloc and then placement new. Like I can't
Oh,
think of a good algorithm to do that in the VM, like
no.
for constexpr.
Okay. I can think of lots, but one of them is I have an interpreter for the language. And then how that interpreter does something is specific to the interpreter. And I don't want that random whatever I do to make that interpreter work to have any kind of impact on the outcome of my final product language design. What I do for what I have to semantically go how the language behaves semantically in the whole. Context expert is like this tiny optimization piece that wants to happen in the middle, and it needs to be correct and blah blah blah, but it doesn't have any impact over there. So those are two separate implementations. If they happen to magically align, I'll take it, and if they don't happen to magically align, I'm not going to have one impact the other.
Mm.
Like pick what you want for your final language. That's the big piece that everyone will care about. Then make your const expert work. And if you can get some overlap there, that's great. But don't bind up what your final language looks like based on what you need to get done for a const expert interpreter. And then I can tell you how I do that in C2 too as well. Simple. I have a very straightforward way to do this in those compilers.
Yeah, I'm thinking that I don't know how I just don't know how you would like do constexpr like implementation in a reasonable way that is like maintaining two separate goals. One is the constexpr interpreter should like detect undefined behavior. Like it's not creating like a memory model of the machine. Like it's supposed to
Yeah.
be like a logical model that kind of catches
You're
undefined
writing an
behavior.
interpreter for your language. That's what the const expert is.
Yeah, but I'm
Have a
just not sure how
compiler
to
for the
do
language,
that
you have
with
an
like
interpreter for the language.
I'm not sure how to do that with malloc and free. Like it doesn't as like an object model. I don't know because like you can't convert between bytes and like a logical object model very easily. Like if you have
Uh,
if I'm making fields not like memory addresses, but they're objects that are like I take a pointer to and do a lookup in a map of the like the field name or
yeah,
whatever.
like JavaScript.
Like
All objects are hash tables when you do lookups and
yeah,
hash tables.
essentially
Yeah.
like that. Like that's kind of how the VM works. If I'm
Yeah.
doing that, then I don't see how I can take like a malloc region and then turn that into an object.
Okay. My point here isn't, oh, I can do this malloc free. My point here is these are two separate concerns that you're conflating. Don't conflate them. Having not conflated them, now I can pick and choose a different implementation for either side of things. And I very much badly want to pick a specific implementation for what my final output looks like.
Oh well, no, these are parts of this is like this would be written directly in the code, right? Like this is like what I'm thinking the type would look like. Like this would be like code. This is not like an IR.
It, I, I'm,
This
I'm,
would be code
I'm
I would write, and I'm trying to figure out like what's the best syntax to that in a way that can work in both
Right. So I'm
as an
saying don't
interpreted
go
and
for the syntax that works in both. Get your final semantics sorted, get your final syntax sorted, get what you like with that, then go backwards and look at it because you don't have to do const expr right away. You can do const expr later. You can just badly emit all the code, compute all the
no,
unique constants the hard way.
constexpr is core to the language. Like everything except like native code runs in constexpr right now. So that's like a core feature is like I know C++ has like all these restrictions in constexpr. Like I've been trying very hard to make sure everything can basically execute in constexpr unless you're like calling an assembly routine or something. So I've tried very hard
I
to
still
avoid.
claim the implementation of the constexpr interpreter should be different from the implementation of your final execution model. If you
Right.
want your final execution model to have these kinds of types, untagged unions, that you have some shared storage, that you put one or the other or the third in, and you just treat it as an untagged, and that's your normal semantic for your normal language, then that's what you want. If that's also usable in your constexpr interpreter, which maybe it is, then that's great. But start from the other side. Don't start from how do I do this in constexpr land? Because there's always a way to make constexpr work. It just is. That's just an interpreter. You'll make constexpr work.
So I don't know how to do this. This is more difficult for sure for constexpr. This is it's doable. Like generic dynamically allocated regions of memory in constexpr. I don't think you can easily do that. Like you could probably figure out an algorithm, but I can't think of like a linear algorithm for it.
Okay, so
Um,
me tell you what I'm doing with simple to do the constexpr like thing, and just to give you a different viewpoint of what can happen. I have these nodes in IR. I have an IR. The IR is intended to eventually turn in machine code after it goes through some rounds of optimization and cleanup. One of the things that happens in the IR is it constant folds. Anything that would land in the realm of a const expr can have a rule that in the IR that says, oh, I recognize this as a constant and fold it. And I do that including with memory loads and storage and with all kinds of things. The only kind of piece I'm really missing for a major constant expr evaluation is to force loops who have only constant inputs to completely unroll. And I could do that, and then I would have a equivalent constant expr that would, you want to pre-compute primes and a constant expr, yeah, you can pre-compute primes or whatever. But for me, there's no interpreter for the const expr other than the standard interpreter that does all constant folding, including every other thing that you would normally consider constant folding. That's all just const expr as a normal IR does it.
yeah, I mean, I can evaluate functions with while loops or anything, and like in constexpr if you want it, you can.
Right. I mean, I could get there. I'm not because it's not the goal of my language, but there are places where that's actually really crucial. So a theme that shows up with modular was wanting to force all constant things to run down to their bit-in constants that included loops over data structures that you're going to feed to the GPU, and they had to take somebody who said I have a large array and I have to break it up in strides of size thread warp or whatever the GPU wanted, and I have some leftover bits on the end, and I have a loop over count of n of them, and da 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 da. And pretty soon you had weird unrollings of all kinds of spaces, which would eventually turn into constants that would then break up how the data was handed off to the GPU. And so you badly wanted to unroll loops as a constexpr and inline as a constexpr and all kind of things, array math as a constexpr, every possible thing. And that was part of what modular is doing, is making GPU friendly code. So it's a great strategy for some domains. It could be what the domain you're looking for. Yeah, you can go make your while loops unroll constexpr. I'm just saying you don't have to have a separate interpreter phase. You could do it in the compiler IR. There is another strategy here.
No, because I need the output of constexpr to be able to be folded into cogen for like I have a
same. I'm doing my normal thing that does effectively constexpr, and of course it's just IR nodes when it's done.
well,
And so
no,
it goes to the cogen just like the normal.
the constexpr inputs can be used as template arguments or like parameters to like different create a class that has a different like
Yeah.
the input to one of the class parameters is like a function call that gets evaluated, and then that produces like an argument to the class that changes its type. So you can't do that without like regular constant folding can't do that
You have
unless
a
you're
you
in
have a
an interpreted
distinction
language.
between types in your system that turn into templating math, which modular does and simple does not but the semantically, I claim they're equivalent. I can do it in simple if I want, if I had that kind of typing system set up. That would be one where the elements of an array, which turn into how the array elements bin back, the stride you use in an array, are variant according to whether it's ints or bytes or shorts, 16-bit or 12 bits or whatever.
Okay, let me paste in an example here. So like in C++, we can have this, like I have this padded struct here, right, where it has this template argument.
Are you trying to
And
use
then,
C++ templates?
Just for the example.
Okay.
So you see how there's like size n as like a parameter to the template, and then this affects like the type. So this is like a fixed size array of n bytes.
Right.
Right. And so in this you can pass, like you can
This
be like,
is
okay,
doable
padded
in the IRs that I normally do. If I allow or force inlining, I do modest inlining. I can require a forced inlining, which
But how do you do that? Because like this is I need to be able to access this during like generation of IR. Like I have to be able to figure out what the value of this is while generating the IR. So
foo as some function in the IR, for me, it's a function that is a pile of IR. And then if I've demanded inlining, it'll inline and I'll get a clone of foo that's specific to the padded guy. And it's a pile of IR bits that then just constant fold, assuming that all inputs are constant, it'll constant fold. And you'll get a constant number there. That happens right now, but that happens like with like any compiler where you replace a template.
This is a compile time thing though. So
yeah,
like
yes. The IRs do the compiler takes an IR and optimizes with it, which means he does things where he transforms the IR from one state to another. If you have a function call that's in a position that's going to turn into your size tn, this function call for foo, I'm trying to highlight it in the mouse, and it's going to be replaced with here, then, and it's important to you that the compiler gives you a constant value there, that's your constexpr tag, then you want semantically to inline foo and execute it as an interpreter is what you're using. For me, that interpretation is I'm just doing constant folding on the IR. That is all it is. So whatever foo says I have something I do, some strategy I do that's available at compile time. So it's not a thing foo can't call out to the standard input and read a number because the compiler is not reading a number from standard input in order to feed the compilation. So foo has something to do that can just constant fold internally. I inline a specialized copy, I go constant folding. Eventually the constant fold completes, foo has turned into a number 17 and I'm done.
So like would you like attempt to constant fold and then just give an error if you need to use this in a compile time context and you can't constant fold it? Like how does that work?
Right. So now the thing that I don't have that I know what to do here that you want to have is to say this must constant fold. And if it cannot, then it's a compile time error. But when you say it must, then for me, it would be I would unlock a bunch of code expansion. I would do things with the IR that I wouldn't otherwise do. Expand the code. So inlining is one of these great optimizations that everyone loves, but actually you can over inline. And so there's always strong heuristics that say, hey, stop at this point. It's just too big. I don't want to deal. It's just going to blow the code up. Okay, if you say this has to fold to a constant, then when I come to that foo, I must inline. So I don't care how much foo blows up. I'm going to make a copy of foo right now. Boom. Okay, that copy is going to take all constant inputs, so you have none, so I don't actually have to do it here. But in general, I would have to have some inputs. They better all be constants because I'm going to do constant math of them. And if they're constants, it's just the math is just what the IR normally does. If you add 2 and 3, it always folds to a 5, and you carry on. After you repeat that enough, if the false kills all this code and blah, 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 after you fold all the foldables, that had better turn into a number, which is what you want your struct padded to be used to declare the size of the array.
Okay.
So
yeah,
for
maybe.
me, this syntax is not a thing that I like, but I'm trying hard to make it be as if this was just a function call input for struct padded, except I want it to fold to a constant. So that this instance of padded, not another one, but this particular one that you make here, has a 17 for its size, as opposed to something else. So a part of your constantness, constant expertness, is that a different struct padded, not this one, might have a different size, but it's always a known compile time, just a 13 or a 17 or whatever. And then that whatever your codegen does with that, he allocates some space of size 17 bytes and blah blah blah, whatever goes on.
Yeah.
And effectively, I'm turning templates into just a function call, except I'm demanding the arguments on the template to constant fold.
Yeah, I mean that's essentially what the interpreter does. Is it's just a thing that can execute the function.
Oops.
But it can execute loops and stuff that I can't do with like basic constant folding transformations.
So this would be something like, I can't use foo here. What's the right here? I don't want to have a function descriptor. He takes an in, whatever. So I'm shortcutting things, but take me my variations here, and I have an int I, and this is a function that's going to return me a padded struct who has, and I'm making this shit up as I go, so I'm going to have some errors in here, but he's going to have a byte array padding equals new byte array of n, except this is a forced constant. So now I have some syntax I don't have where I want to demand so that when I get done running my template-y name, I don't want to use template here on you, whatever, my call my template with an in expression. So somewhere down here, I'm going to say make a padded thing.
But wouldn't that like how does the type get passed down as like it sounds like this is like a dynamically sized byte array rather than a fixed size byte array in this case.
It's dynamically typed in its definition. It's statically typed because the demand here for a forced constant, I want to actually demand it here. I don't have syntax for that. So I want to have some padded here that has to be, I'm going to use a pound sign to mean this must be a constant all the way through. All bits are going to be turned into some sort of constant description. So that's going to require foo here to be constant folded. I'm making up syntax for force foo to constant fold. And the new template will give me, the output of the function call here. It's not a new template, it's just a function. I'll just call this and he'll return me, here's return. This struct padded where this has been forced to constant, this is forced to constant, the whole thing has been inline and forced to constant. Padded P will come out to be some structure, which is some wad of bits, which is of size 17, right, of a padding bit plus your index or whatever it's going to be here.
I don't know. Mixing the IR and the interpreter seems difficult.
Yeah, what I'm doing here is to claim there's only one language, and you're going to write it in that language and not in two separate, like a meta language for the interpreter and another language for the regular things.
Well, there is only one. There is only one. Like that's okay. Kind of like.
And then I'm trying to say, but I can force you to constant fold all the way out to the final bits, and in that case, instead of being a dynamic runtime call to template, which makes a dynamic padded thing of size 17, it will make a global constant with 17 bytes long that's called padded and has an X after it or whatever. It's going to be the X is in there somewhere.
Yeah.
I guess I should say X here.
So the way that my language works is that we have source code. Right? Source code goes to QXIR, and then that can go either LVMIR,
right,
or this can go to constexpr. So this like QXVMIR.
Yeah. So I would have a simpler version, but it's semantically, it's similar in the head. Source code goes to simple CF nodes. That will do the constexpr already. And when all of those are done, it'll go to my backend, which is an LLVM, but it'll go to my backend for the code mission.
Does this require you to have some duplication? Like, I know in the early days of Java, there were a bunch of bugs that were the interpreter and the jitted code didn't behave identically.
Yes.
And it took a while to chase all those down, which eventually
Yes.
they did.
Yes. One of them was rules like people didn't have a strict FP. And so I came in with like, yeah, floating point math is associative, commutative, blah, blah, blah. I'll reassociate, fine. That had to off by, least whatever, one ULP, unit least precision bugs that the FP guys screamed and yelled about. And then strict FP came around and eventually I think even became the default. That was one of them. I'm trying to think of other places where the interpreter, a lot of things were weirdly like the C2 stack frames are vastly smaller than the interpreter stack frames, especially after inlining has kicked in and cleaned everything up. And that meant stack overflowing tests would die early in the interpreter and would run longer in C2 because his stack frames were smaller. And you
So
could get call tail elimination and it would just turn into a loop. It would
so
never stack overflow.
my approach is instead of constant folding, I just execute the IR at a VM, and that means that it can have loops and it doesn't have to solve the halting problem, right? You
Where
could just
you've
set
told it that he should run the loop and he doesn't solve the halting problem, but he'll just run forever if he's not gonna, if the loop's not gonna halt.
right. Or you could say, okay, maximum, instructions to execute equals blah, and then if
That changes the
error.
semantic of your language. What you can do
Exactly.
that, but then you might as well just say I have a for loop that I've clipped it in for I equals, 0 to minimum of I comma int max or whatever. As soon as you said I have my interpreter has a bailout, then you change the language. You reject some programs because you took the interpreter bailout, or you took the interpreter bailout, but then you didn't make it a const. You ran it at runtime to go build the value at runtime, which in many cases is just all fine. The GPU model is different in that if you don't get it down to a compile time constant, you can't go to the next step where you lay it out on the GPU. So that's a hard fail. I didn't compile your program to onto the GPU.
Well, there's not a lot of like optimistic folding. Like it's just okay, this is appearing in a template where it's a compile time thing. Therefore, we execute a compile time. This appears anywhere else, it's LLVM. LLVM can do whatever constant folding it wants,
Right.
if their optimizations are on. But
you
it might
have
not.
You have a problem where you have a backend that will not do as much constexpr as you want, so you have to do it and then call the backend for the rest of the things. So that we get you in a zone of, oh, maybe I need an interpreter. All I was trying to show is, hey, you can do this with one IR and one backend execution model, whatever. It can be done. Is it what you want to do?
I just don't see how you can like there are programs that halt that I can't see how you can create like a general purpose constant folder that can like solve every because there'll be situations like it doesn't know if it'll halt, right?
That's correct.
And
Go prove
so
Fermat's last theorem by running the triangulation or the Collatz conjecture, looking for the counterexample, and then print the counterexample as the optimized final code. Well, now you're often an interpreter of a program that doesn't halt or may not halt. No one knows.
right, but that's why I'm saying like let the programmer control when it's like give the programmer control instead of just saying, okay, this is a constant folding thing.
I'm doing that with syntax. I've added syntax into my little made-up example that said, force it. That's the programmer saying, do it anyhow, which means if he has a while loop that happens to never terminate, well, then he'll never terminate in the compiler.
I'm not sure if executing a while loop, that sounds more like an interpreter than constant folding though, doesn't it? Like, are you constant folding at that point?
See, this for me is I got my head past that point a long, long time ago. And that's because I do the exact same code, implementation, algorithm, everything it's the identical code for doing control and data. There is no difference. And as soon as I do control and I run the same algorithm, I do 2 plus 3, it's the control is if false, if true, also folds identically. Now, is that constant folding? For me, it is. You can call it what you want. I make no distinction between if false folding and 2 plus 3 folding. deep in the bowels of the optimizer, which can double as a constexpr evaluator, I pull some chunk of IR off the work list. I ask it to optimize itself. It's all a local thing. If it's 2 plus 3, it is. If it's an if and a false, it is. It does what it does. And then and I go lather, rinse, repeat on that loop until I run out of things to do. And that, from my head, that's constant folding, but it happens to pick loads through stores. It picks store after store optimizations. It does memory. It does control. It does data. It does all the things. It's all the same. So you can claim that's my weirdness, but I've been doing that for 40 years, and that seems to work well for C2 and Hotspot.
I see.
So call it what you want. You don't have to call it constant folding. But in my
it's
head,
evaluation at the end of the day. It's evaluation either way, and you may evaluate in the interpreter or you may evaluate in the constant folder, but the evaluation strategy may very well be the exact same code.
Exactly. I'm doing evaluation, partial evaluation, and if I've demanded something to evaluate down to a constant, then I'll partial evaluate becomes a full evaluate.
Clang is currently switching to the bytecode evaluation strategy in its interpreter for constexpr, by the way, which may be relevant, although it's a work in progress.
Oh, LLVM is?
Clang, not LLVM in general, Clang specifically, just the C++ frontend, specifically for constexpr.
Is moving from, I'm sorry, from
From tree walking. Previously, it had a very, well, it still has, because that's the main option. The current default is to walk the AST, so it's a tree walking interpreter essentially, and that's rather inefficient.
Okay.
Is my audio still
trying to
by
get
the way?
faster. The goal is to get a faster constexpr.
Yes. Is my microphone still poor, by the way?
It's better.
Okay, interesting. Thanks.
I can hear you more clearly now. Like, I never know if it's at your end or the interrupts in between, or like, what time zone are you in? Are you in Canada somewhere or something?
No, Central.
Central, okay. But a long ways away.
Yeah.
So I don't know. Some provider, internet provider in between here and there is fiddling with your audio bits, or you have a setup on your end.
Yeah, I don't seem to have the issues with other, just the Zoom, which is strange.
Well, oh gosh, we're like 11:30. I would love to play with this as const for me to make sure that what I just said actually works by actually doing it. I'm guessing it works. It looks like it should always work completely down and solve the same problem. Having said that, I haven't actually done it, but all my copious spare time, right?
Yeah, I've been implementing a bytecode interpreter, so I think that it's not exactly a bytecode interpreter, but very similar. Are they doing like JIT on the Clang front end?
He said AST interpretation.
I know, no, I meant the new one. I know the old one used AST. I'm like, he said they were using.
I would call this a bytecode. It's not the JIT like the crank REPL is. There is another project which basically gives you a REPL using Clang, and that's a legitimate JIT that actually uses, I think, org JIT. But I don't. Bytecode interpreter is a custom-made implementation just for constexpr.
So I have a bytecode execution just for constexpr, but you could imagine taking the bytecodes and turning that into a JIT if it was a big enough pile that you wanted to constexpr it. Runtime, compile time. Blech. Like I know Joe Blow was on here once, and he has a lot of things he does for games where he does complicated things that he wants to constexpr basically, boil them all down at build time, so that at game time when you have to do 60 frames a second, you don't have any work to do. You'd be morally the same. Yeah. You're going to say something, right?
I was just gonna say, I was just curious, like, how that constexpr interpreter would work, because that's
you got to get bytecodes.
Kind of similar to what I'm doing, because I have my own, like, it's not exactly a bytecode because it like has pointers inside it and structures, like, but
You get
it's kind
some
of like,
IR, whether it was bytecodes or an AST or whatever, and you have a walker for it. Simple has a walker for the tree of nodes, the evaluator, which I run a bunch of tests with. So I can evaluate as an interpreter sea of nodes. I don't claim it's a good interpretation format, so it's not particularly speedy, but it has semantically has the same semantics.
yeah.
Might be faster than unrolling in the compiler into the IR and then folding it. Just have the interpreter, the evaluator, take a chunk and evaluate the loop that way.
I wonder how long the latency is for evaluating the sea of nodes versus doing a sort of tier 0 JIT.
Yeah, exactly. I mean, we can look at what he does. He's not, like I said, he's not terribly efficient, and the IR is not meant for interpretation. So
But if
you can
that
get a
can save
10x speed
Simple from
up.
having both an interpreter and a JIT.
If I was to have a JIT for constexpr things, I would take a chunk of IR that someone demands, has a while loop and someone demands that it fold to a constant, and I would break it out, finish the compilation on just that chunk, run it, get the answer, then go back to compiling. That would be, a JIT within a JIT, right? It got the back end, got the front end, got the IR, got all the parts. You said, take this while loop, which computes the first million primes and tells me the count of them. And you want it as a compile time constant. Well, okay. Take all the other stuff, set aside, take just this, put a function called entry exit, restart the compilation as a nested. That gives me a binary, a .o, run the .o. It gives me a number, 17,000 primes in a million. I don't know, whatever. And go back. I mean, this is a thing. It's a bunch of work, but it's no more. It's just plugging the parts in now. Now, having said that, yeah, I think I'd be easily 10x. That interpreter is not super good. Future projects, right? All right. I'm going to wrap it up here unless somebody has something else to bring up. Somebody has JSON code block for. Is someone trying to say something there? There was a mystery start of a comment. Didn't happen. All right. Well, good enough.
I have a non-blocking hash map question for you if you have a moment.
Absolutely. Yeah.
I have been I spent the last couple weeks writing a compact hash map, not meant to be concurrent, and but just save a boatload on memory since Java util hash map allocates all the time.
Yeah.
And I was comparing to how you did things, because I tried to do open addressing in the first place, and like key clustering from collisions was just killing me.
Yes.
So I was looking at how you handle it in non-blocking hash map, and I'm trying to figure out what load. It looks like you have a static load factor. I can't quite work out your math. It looks like you have a load factor of a quarter. Do you remember?
Yeah, and we can pull a code up here. Assuming I can go find it in real time. So I picked up a key spreader from Doug Lee to help with the keys being
Yeah, I was looking at the hash spreading, and I was surprised to not see that it matches what's in the JDK. And I just tried that out. I threw that into mine. I was just using the same one as HashMap, and it actually made things a bit worse, but my keys are probably too evenly distributed.
Where do I have Simple doesn't have a copy floating around. No. I'm trying to think where I have an easy copy lying
I can
around
paste in the chat just the where you compute all this stuff. I don't have the Google. There's the Google Doc here somewhere.
You have a link. Wow, a bunch of people. I haven't read chat in a while.
Oh, there. I pasted the relevant code in the chat, but I should get on the Google Doc.
I have a version here. This is not too old. Let me let me share and screen size and blah, blah, blah. Where's my zoom? Where's my share? Um, is that like readable now?
Yep.
People can read that? Yes, no?
Yeah, that looks good.
Good enough.
Yeah.
Okay, so where's the hash spreader?
You have a function called hash. But I was
Yeah,
asking
right.
about the load factor, which you seem to have a constant load factor. And
Right. The load factor, well, it's same as did I call it load factor?
no, because it's you when you compute the initial table, it like
Yeah.
happens, and I assume after that you're just doubling, so you don't actually have to maintain it. But
Um,
your way of computing it is
somebody
pretty.
gives me the damn, you can take it from online. Here's the hash spreader. That's
Yep.
that guy. I got that
But
straight
if you
out.
look at the initialize method, I think that's where you're
What's it called? It's not called initialize.
in it.
It is.
Well, I might be looking at.
This is okay.
Oh,
The
okay.
default start for the table. You want the load factor or the
I
default
was
table
looking at
size?
the version of your code that's been morphed in JC tools. So it looks like
I
they've
got
changed
the
it a bit
JC
since the
tools
version
in
you
my.
have.
Yeah, so the initial table size is basically one. I have to have a key value pair slot, have to be aligned. So there is a slot for the nested concurrent hash map object because that lets me update the table in one CAS operation instead of two, which you can't do atomically. And then
No,
after
but
that, it
the
has
for
room
loop
for
two lines up though, right? Like there
right.
you're
Minute.
yeah.
Uh, Yeah, I screwed around with this and decided that I wanted the small. This is the smallest size you're at. This is not a load factor. This is
But you're
default.
taking the initial size hint that the user gave you,
Yeah, the
right?
initial
And
size.
then
Yeah, yeah. If you don't give me a size, you get one key as your initial size. And if you give me, or maybe two, and if you give me a key size, I take whatever size you give me. And then I take the size you give me and I do the scaling math to allow that many values to be held in the table.
So
right,
you're just
which
rounding up
at
to a
that point
power
you're
two.
computing your load factor, right? So it's more than running up to the factor two, right? Like you won't store that
Yeah,
many keys, right? So
right, right.
your
When you want
limit.
load factor, which isn't that's initial size. You want load factor. That's the reprobe math, reprobe limit here.
Oh, you manage it through reprobes. Okay. So
Which
you
is
just automatically grow. And I think I saw it was like the reprobe limit was 10 plus a quarter of the
yeah, there's
size.
some limit here. There was a right, and the load factor they gave was not reasonable for this style table.
I thought with the like
Yeah, that's a
growing on
plus,
reprobe,
yeah.
you can get into just endless growth, right?
I'm sorry, say
Yeah,
again?
you definitely can, right? If you reprobe simply because a collision chain or a cluster got too
Yeah.
large, then you can suffer from endless growth,
Well,
right?
I have a cap on how big I'll let you go for so few keys. Like if you all your keys hash to the same thing, they all have the same
Okay.
hash value. So
Yeah, exactly.
you're basically making a linked list, not a hash table.
Yep.
Then I believe you get capped by the reprobe. There's a reprobe count for a ratio of things that I'm not finding it right now because it's been a long time. This is like a 10 years since I looked at this code. Um, you skip 10, you go to the reprobe limit math, and then there's another one that says don't bother if you've gotten too big.
So
Um,
then you don't expand and you
yeah, you suffer
do up
the
to n search. Search up the entire array.
Yeah, eventually. Right, right. If somebody has you
Yeah.
only one hash value, right? Everyone
Right,
hashes
yeah.
to zero every time. Not saying that I've ever seen that in practice, but of course I have. So you don't have a hash table, you have a linked list. All right,
Yep.
now how do you want to implement your linked list? Okay. So one of them is I throw you into an array, I tried to scramble, it didn't work, they all piled up here. Then I did my reprobing math, which does a quadratic spread, which doesn't work if everyone has the same hash. So then they're all, dink, 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 dink. They wrap the table identically, and then they probe identically, and the lookup is just walk the linked list. It's basically walk an array list with a mod function, with a funny offset and a mod function. Okay, that's what happens. And the growth is supposed to stop you from keep going if, even though the probes are bad, the table is way bigger than it needs to hold the count of values. So just stop. It's not working, right? That's the reprobe count. I believe that's what this one is. This is saying, hey, I think that I have
Wait,
it's less than half full.
Question: if you have a linked list, is this a hash map?
This is I'm saying linked list, Ryan. A hash table crucially depends on you having a good hash function. If your hash function is the same value for all your keys, the theory behind hash tables doesn't work. And all of them, by theory, must degrade into a linear scan of some kind. Either a linked list.
No. It's the difference between a hash table and a hash map is that a hash map, if they're hash collisions, they put them into a tree and do a binary search.
I don't think table versus map has a official.
The Java implementation puts them into a tree and assumes that you can do a comparison between two of them that has a lesser or greater operation. That is a new thing that Java did. They didn't start that way. Their original hash map or the original hash table was not synchronized correctly.
That was in response to attacks.
To what?
People were feeding strings in to like database, like into a web server.
Right.
And they knew that if they fed enough of them, they'd build up like these huge chains and degrade performance. So the binary search or the tree was put into hashmap to
But what does the tree use to declare your lesser or greater?
Your hash code.
All hash codes are the same. So what's the lesser or greater?
It's still hash code.
You compare by the hash code, and then if the hash codes are equal, you compare by the object value or the key, like to do a comparison of the object type.
You can't because it's equality based.
Yeah,
you can have like you can support multiple hash codes, but you still get the linear scan. So it helps in the case where you have a lot of collisions, but not identical hashes. If you have identical hashes, you're still screwed.
Right. So if I have non-identical hashes, I assume my quadratic reprobing spreads you out.
How can that be? Because you just have hash collisions by chance, and then if you can't compare the objects...
No. By design, I'm forcing all hash collisions, 100%. By design, my hash codes are all the same value.
How could that possibly be Java's implementation? Because how do they deal with, like, if the objects are, like, they have to be able to check if the objects are equal, right? Because otherwise you could just randomly have a hash collision and then you look up the wrong value.
Use an equals call. But to do a binary tree, you have to have a comparison that's less or greater, not equals.
Not true. You can have equals.
But you don't get a binary tree out of equals. The binary tree says I want lesser or greater, and that is a property that...
you can do a binary tree with less than equals or greater.
Yeah, you can, but you have to have that. Here I give you opaque foo objects. I make a build.
I think we're probably talking about too many things at the same time, right?
Okay, you're talking about an
yes, you can have.
And I'm telling you what you can and cannot get out of adding a binary tree to defend against an attack on a hash table. To make that binary tree do something useful, it has to have a stable sort. You're effectively building an insertion sort. You have to have a stable sort value. So you can't use.
And the only thing we have to work with is the hash code.
But why not anything else? Why can't
because you don't know anything about the object. It's an
Java doesn't give you anything else.
Yeah, it doesn't give you anything else.
You have an equals function. You should be able to have a less function that returns a bool.
You do not have.
You can, but that's not a requirement of hashmap. Hashmap says as long as you have hash code and equals, you can be a key.
That's correct. So I'll give you an object. I make a hash table with objects.
You can use tree map if you want to, have ordering.
If you have ordering, you can use tree map directly. It's login, but it's guaranteed login, which is exactly what they're doing with the hash table. If you were ordering, you could do something. He doesn't actually have ordering, so he's hoping the hashes are different in order to order, and they're not in my counterexample, which means I can break the hash table versus hash map just the same exact way. Same attack works for both, just the same.
Your argument is still for the case where everybody gives you one.
Yeah, everyone gives you the same hash.
If everyone gives you the same hash, you're not
I have
you're not
totally
hashing.
Well, you're now in linear scan land because you have to call equals on everything.
That's correct. Even on the hash table, which has this binary tree, it still doesn't work. It's the linear scan on the binary tree.
What is with the stable ordering requirement? There's no promise that the hash table is going to give you the first thing that's equal.
No. I have
strong ordering, not stable ordering. Strong
No,
ordering.
You need a strong and stable ordering. It has to be both. So here's the attack. I make a foo object. It doesn't have comparator, so you can't do a less than or greater than. It just has hashCode equals. I make a billion of them. I make the hash always 0 or some constant. Everyone agrees it's all the same constant. I throw them in the Java hash table. He says, oh, I'm getting too many on the same hash chain because I have a billion. They all have the same hash. Great. I'll put in my tree. What does my tree use compare less than? Well, I can't call less than on them because I don't have that. That's not a function called
it's left.
Yeah, I just pull hashCode out. It's all the same. I go left. The tree just drills down a left spine a billion long, and oh, look, it's a linked list. So it's still a linked list lookup in the attack that says all hash codes are the same. It does not help you. What it helps is if the hash codes are different, but they happen to be hitting the same hash bucket. Now, why are they hitting the same hash bucket? Okay, that's a bucket problem, and that's a design of how that is one of the ways that bucket tables have their issues. In an open coding, you have these chains within the table, and for me, if your hash code is different, same as with the other guys, if their hash code's different, there's a rescue. My rescue is I do this quadratic reprobing. If your hash codes are different, when you hit on the same point in the table, the one guy strides this way and the other guy strides at a different size, and they end up in different places. And
so I am reading that they say that Java 8 turns it into a red black tree. So that you're saying it only uses the.
How does he order two things? So any of these trees require A less than B. Compare them. Now you can't call compare because that's not in the API, so you can't ask the standard compare. You can't compare on pointers because GC, so you have to do something else. What you have is hash code. So I'm comparing two hash codes. Well, it's 0 versus 0 every time. So he can only make the same decision every time. So his hash table is a linked list. His red black tree turns into a linked list.
That's funny. His hash table turned into a red black tree, which turned into a linked list.
An expensive way to do.
Can we get any other data structure transformations out of this?
Yeah, right. It's an expensive way to probe a linked list. And he wasn't trying to rescue the no hash. You can't. So if you have no hash code, you don't get a good answer no matter what. You get a linear scan. That's how.
Oh, okay. So apparently it checks if the type implements comparable.
Right.
If it does, then it does
that.
It's what
it really shouldn't.
Almost surely I can cheat on that one as well. But the easy one is just not implement comparable.
Oh, no. Okay. Apparently it does fall back on comparable. Wow.
What happens if I send objects, some of which are comparable and some of which are not?
Yeah. Right. Then it will have to switch to hashcode.
You have to be stable. And here some of your objects do not have comparable and some do. And you get stable on the ones that are both comparable, but if one is and one isn't, now you go back to the hash code, except the guy who's comparable is stable against that's a weird. Maybe you can get a sort out of it.
It does. I just checked the code in Java 17. It does use comparable, which scares me.
Yeah.
That's so wrong, right? It would have been right if it had been in the doc for HashMap in Java, whatever 1.2, whenever they introduced HashMap.
Right.
But to retroactively put that in there, oh yeah.
If you're comparable,
we'll see if this works.
And your hash sucks, we will then attempt a red black tree on you.
But apparently, it's been fine for 15 years now. So
yeah. So it works, and it probably rescues some fraction of terrible hash tables. I have met any number of hash code implementations that did such stupid things and always ended up, I say 0 versus 0, but they ended up with constant versus constant all the time. And degrading to a linked list was like a thing that happened on a regular basis.
I was very surprised in my testing. I thought I had a bug in my implementation because I ended up with chains with 10 items in them. I was just using, random to generate my keys. Like
Sure.
what's going on here? And then, I checked HashMap with the exact same input. I'm like, oh yeah, it also gets deep chains of, 10 items. Like,
yeah. One of the
like I
things
just thought, like with a good hash, which like, okay, hash of an integer that was randomly generated should be good, but like you can get these really, really deep chains.
Somewhere in this world, I had I don't know, no, I didn't end up in this code base where I would give you a histogram table layout. So no, I don't have it in this code. Give you a histogram of your keys and probes and where they landed and who paid. So you could in that particular output that's what the record stuff here is for getting that info. And I have a pretty printer elsewhere that I use in various times that says, here's all the keys and where they've bunched up, and here's the thickest, longest key chain, the keys that are in it.
I added things like that to mine as well. Like you can just ask, like, hey, how many collisions does the map have? Or for this key, how many people is it colliding with?
Exactly.
And
yeah, that's
very,
what
very helpful for
right.
debugging.
And then you go through. Look, I forgot to switch on interesting bits, and it's all turned into I've shifted right by 63, and I'm only getting one bit, whatever.
One other question I had about yours was I was a little surprised about the cache friendliness. Like I keep my keys and values together, but you separate them in the storage array, and then you have
keys and values are
again the version that's in JC Tools puts all the keys up front and all the values at the back, which I thought was really weird. It's like, wow, let's guarantee a cache miss.
Somebody didn't tell me about JC Tools doing that. I'd have shot him in the head. So
I mean, I could be misreading, but I don't think I'm misreading.
Okay, long hash map does the longs in a separate array because it's not typed.
Well, yeah,
Java. But the regular guy is keys and values here. Where is my key value offset?
So
here?
Interesting that JC Tools chose to do that. The only reason I had considered that is while you're probing, you benefit from. While you're probing, you're better to have just a bunch of keys, right?
Right.
So you have twice as much data in your cache, but it felt like a loss to have once you bind your key, a guaranteed.
Yeah, then you have to cache miss again. Yeah, here it is.
Yeah, and then similarly, the separate index array, which obviously you have to have. Sorry, separate hash array.
Yeah,
like it was also like darn, that's going to be a cache miss.
So here is the +2 and +3, so they are adjacent. Scale your index by 1 and pick even or odd. That's your key value. Yep. And that was not, boy, do I have JC Tool? I've had it online. I have a copy of it. I haven't looked. I haven't pulled in years. I could go see what they did. That would be a bad thing. Yeah. General loser.
Yeah. Trying to see if I can find it real quick. What's the function is called? Val? Yeah, there. No, I'm just reading everything wrong today.
Oh.
It's right.
It's done the right way.
I don't know what I was thinking.
Yeah, here's the reprobe loop. Get a key, and I get a value right away because I need to have them with a volatile. There's some reason I need to have them near each other. And then there's check to see if you're in the wrong table, and then there's check to see if your key is equal, and then check to see if the value you got is already primed, meaning that you're on the wrong table anyhow. Then bump your reprobe, and if you're not less than the limit and you didn't get a death, then why is this a fail? Oh, no, this is I went to a new table. Otherwise, I do this weird math, and this is the divergent reprobe chain. This is my quadratic probing I was talking about, where I take your full hash and the index of where you're at, and that is included in the next reprobe. So if you've landed in the same spot, mod whatever power of 2 amount on mod 16, you're on the same table. But one of you has a mod probe that's +7, one's +9 or whatever, they happen to hit whatever, one's 16 and one's 32, then I'll take the extra weird bits and the next reprobe will be different for both of you. And that'll force you to diverge away from hitting on the same spot to break up these long chains.
So while we were talking, I had the performance tests that I've been running all week to compare my hash map to JDK hash map. Like, let's run it with non-blocking hash map versus JDK's concurrent hash map. Yeah. I'm sorry to tell you, Cliff, concurrent hash map wins by a lot. But I'm not accessing it concurrently, right? All my stuff was single threaded, but like for gets, like concurrent hash map is like 3 times as fast.
Oh, that's interesting. There's definitely a time
but
that is essentially within 10%, except when you did writes intermixed with other things, and then I beat concurrent hash map up by a lot. And they might have beaten on it some. There's a lot of stuff going on here right now to set up for this. I'm curious now.
I mean, I think it's probably a lot of the things I was fighting through. Like at the end of the day, like you lose because you have to jump to your second array of hashes where concurrent hash map has nodes. Like, so it's just right there. So like
one less cache miss.
While things fit in cache, they're very, very lucky.
I take a cache miss here and they do not.
Yeah.
Do we know how often hash maps are what sizes?
Yes.
Like to some extent, it might be worth taking the advantage on really tiny hash maps, even if it has some costs on big ones.
Right. And that's the answer, is that the common case is that hash maps contain 0 or 1 item. And you never needed a hash map in the first place. And I don't have that optimization.
I hope that's a common case. It's unfortunately common.
It's unfortunately common. Yeah, I totally would think, given the minimum overhead I have, which is not huge, but there's a minimum overhead, I could have a tech up front that said the size is small, my type is this funny thing, it's just a list of 2 or 3 words of keys and values. And that's how big you are until you're one object and all the keys and all the values are all right there until.
But the cost of that check. Cost of that check ends up killing you once you cross into reasonable territory. Then it's like, oh goddamn, the extra like 2 branches that I do up front that are no longer benefiting.
The 2 branches, right? But I'm saying if some fraction of hash tables have like 2 items in them, so so everyone is whatever, like 50%, 4 or less. Then I have the 1 branch, and you go to the 4 or less linear scans all in one cache line, no more cache misses. Or you're 4 more, well, then I'm probably going to pay a bunch of other overhead anyhow, and 2 branches or 1 branch there shouldn't, knock on plastic, count hard against you. I am kind of curious to see what test you ran that you got a significant speed gain, because I have fevers out of this.
In my case, I'm putting in 1024 key value pairs, and then I randomly select 16 of them and just call get on those 16, right? So it's I'm hitting the same ones over and over again. They're going to hit on reference equality, right? And in tests where it's on stateful equality, then non-blocking hash map is only like 20% slower than concurrent hash map.
Okay. I'd have to.
But it was just interesting the endpoint. It's going to make you pull out non-blocking hash map and get it ready for the 21st century.
Yeah, it could be needs a tune-up.
I got here by profiling my company's like our application, right? And like looking at like the reverse icicle graph and basically realizing like all we are is a hash map. Like just everything eventually comes like we're spending all of our time in hash maps.
Yes.
Like okay, maybe an area worth optimizing.
Yeah, I'm looking at like what do I do on a get? Well, I call it get impl. I go compute your hash. I do the hash scramble. Maybe should have cheaper hash scramble. I go get some values out of my table. Those should all be field accesses. And then I make another cache miss for the hash. Assuming you have a pleasant value, then the key value pulls up. I don't get there. You're not growing your table. I do the key compare, which does the first obvious thing.
My guess is you're losing on the on getting that out of the hash array, which is you have to do that because you're open addressing. Like you'll die without it, but I think that's probably where you're losing.
Yeah, and it could be.
So I went through all these kind of machinations, and I ended up with an approach where I'm like open addressing like when you don't have a collision, right? I store directly in the storage array.
Yeah.
But when you do have a collision, I store a chain object which contains initially 2 keys and 2 values. And then if you insert another one to that, it's like it blows into a chain n object that's array based. So it's like you're still far, far more compact than HashMap, but you don't have any clustering issues. You have your hash codes packed right next to the values. The keys and values are right next to each other.
Yeah.
But you allocate on collision, but the amount that you allocate is still trivial in comparison. So I'm coming out in the area of like between 3x less memory than hashmap or 30% less memory than hashmap. So it's like,
Yeah.
and it just depends on collision rates.
It's
But
easy to beat
it's
hashmap.
like, oh, open addressing looks so nice, but the pain in the details of maintaining that separate hash array.
Okay. Well,
So, anyway,
my copious spare time, I might take a look at this guy, see if there's something to be done with being even more cache friendly. He was at when I first came out with him, he was way the hell more cache friendly than hashmap.
Yeah. If you decide to play with it, I'd be happy to send you my JMH test that is showing this. So
yeah. Okay.
All right. Well, in that case, I will send it to you.
You can send it to me. I don't promise. I'm going to hack simple because I'm
No.
going to get that done.
If you ever decide you want it, then I'll send it. But yeah.
Yeah.
Why go there?
All right. And he threw it in the chat,
that's the problem is you keep optimizing stuff and then they change the hardware.
Yes.
There is that.
What is this? This is something else. You threw some amount of your. You've cut and pasted some pieces in. This is where you got the Java C, the JC tools guys. Yeah, see what they did. That doesn't look bad right there, though. That's not directly the mistake.
No, but yeah, line 8, I was just scratching my head on for a while. I was like, okay, but I thought I was also sitting on a call with the author. I'm like, why didn't I just ask? But yeah, this is not your code.
Okay. Fine. Well, that's it then. I'm going to declare victory and run away. And nice seeing you again. All right, folks. Till we meet again. Bye-bye.